All right, question 6a. It's fairly easy. You know how y equals mx plus c, and that's the gradient? Well, here the gradient is a. Okay, for b, write down the inverse relation. So if I've got y equals ax plus b, swap x and y. So we've got x minus b equals ay, so y equals 1 on a times x minus b on a. For the inverse to be a function, the original must pass the horizontal line test. So for the inverse to pass the vertical line test, the original must pass the horizontal line test. If we have a straight line, these are my axes, and this is like any straight line, it will always pass the horizontal line test unless our original line is a straight line. And this is when the gradient equals 0. It's the one that's straight across. It's not undefined. It's just this is 0 fun. So a cannot equal 0. D, when the inverse is a function, solve it for y, find its gradient, and explain why the gradients of the function and the inverse both have the same sign. So y equals 1 on ax minus b on a. The gradient of the inverse is 1 over a. Explain why the gradients of the function and its inverse both have the same sign. Well, it's because we're reflecting around y equals x. We're not... it's because it's the reciprocal. We're just doing 1 divided by. We haven't changed the sign at all. Give an argument using the line y equals x for your answers in part C. What was my answer in part C? Well, if it's reflected in x, this means for the initial one, the gradient was rise over 1. For the new one, it's going to be run over rise. So rise cannot equal 0 because it's on the bottom of our new gradient. That wasn't too bad.